Hello. In the problems you asked me about, I'm going to do some examples from the book similar to those. So in 46, this is a definite integral since I have a lower and an upper limit, but I need to go and integrate this first. Now if it's not e raised up to a single letter, then I have to do the u substitution. So I'm going to go to the side here. I'm going to let u equal x squared, then du over dx would equal 2x, one of my daytime students said you just interchange these two, and technically that's what you do. This is always over 1, and these are called the means and extremes, so if you can just think about interchanging them, you can get to this point a whole lot quicker. Now my next step, and this is why it's called substitution, that would be e to the u times that du over 2x. Whoopsie. And now I'm going to clean up. Notice the x's eliminate, but the 2 is in the denominator. It must stay there. So that would be 1/2 e to the u du. Because everything, when you do this u substitution, everything has got to have just the letter u in it once you've cleaned it up. Now when I integrate this, what's nice about e raised to just a letter, it is its own antiderivative. But now I'm not going to put my limits on until I bring back what u was. So that would be 1/2 e to the x squared going from 0 to 1. Now I do my 2 parentheses. And when you do it by hand, remember that the upper limit is substituted first and then the lower limit. So let me get my calculator. And I do like to use storage, so 1 STO in for x, and then I type in my function, so 0.5 second e to the x squared. So I get 1.359140914. Type in 0, second enter, and I get 0.5. That's because when you put 0 in, anything to the 0 power other than 0 is equal to 1. So now I've got 1.359140914 minus 0.5, and that gives me, and I think they wanted you to round to 3 decimal places, so 0.859. If it were 4 decimal places, then it would be that. So that's that first one, and I have to use the u substitution. Now the next couple of problems, let me get my page out of my notebook here. Refers to these. Now when it says use a numerical integration routine, that means use your calculator. You cannot do these by hand. So I'm going to do the even ones. If I can fold that and bring my calculator back in where the light won't interfere. I know. I'll do this. Yeah, I can do it that way. Alright, so let me clear. There's a couple of ways you can do this. One way is graphically, which I think is cool, but I go to y equals, and I did this in the videos. You put in your f of x that's behind the integral sign, if I want my calculator to do it. Then I ask it to graph. And I wait. And there it is. So now if I do second trace, anytime I want anything off this calculator, if you'll notice number 7, that's exactly like this. And that's why I have to put in the original, because I need it in that form. So I'm going to press 7. Now your calculator will ask for lower limit, so I type in -1, and the upper limit is 1. And there's my area right there. And I can use this to check my other problems too. In 46, let's go check 46. I type in my original, so y equals x second e to the x squared. Ask it to graph. Okay, and now I need to go from 0 to 1. So second trace for the calc menu number 7, 0 to 1. And that's what I got right there. On this one, this is the one with the new operating system, so I really do not know what kind of calculator you have, but the 83s and the 84s, they'll all do this. So there's another problem. Let me look at 66. So I go to y equals second square root 9 minus x squared. Let me get out. Let me go ask it to graph. I need to go from 0 to 3. So second trace for the calc menu number 7, lower limit 0, upper limit 3, and watch it color it. Oh, it's so cool. So that would be 7.06, 3 decimal places, 9. So let me write that down. 7.069. And this is for problem 66, because I'm going to show you another way. And again, it depends on your calculator, so that means I need to do it 2 ways. So let me clear this off. The problem with the graph is if your integral, say, goes from 0 to 10, you'll end up with an error message because my x values aren't big enough. On the word problems, which I'll be doing one in just a second, on those it is easier if you do it by this next method. So let me clear this off. I go to math. Do you see number 9? It's function integrate. And if you'll check this out, I just type it in exactly as I see it. So I need a 0 there. Whoopsie. I use arrows. Yeah. Okay. 3 there. Shift square root 9 minus x squared. And I type in the x. And that's what we had. I just like the graphing because I think it's pretty with the coloring and all. If you got the other calculator, let's see. I have to change mine. Let me go to mode. I gotta go back to classic. So if I do the same thing, math 9, if you'll notice it's a little bit different. Now the order I put this in, I put the function, so I'm going to do 46 because I have an answer for it. So I put x second ln x squared. So if your calculator, when you hit second ln and it comes up with a caret symbol and a parentheses, then you've got the old version. The next thing, so let me write this down. Function integrate. You type in your function, comma. The comma is right above the 7. So I press comma. Then I type in an x. That's indicating what the independent variable is. Another comma. And then my limits, 0, 1. So this is upper limit, excuse me, lower limit, upper limit, in parentheses. And that's what we got for this one. So on the word problems, you need to set up the integral, but it would be easier if you do it this route. So I'm going to go back, switch my mode. Now, I guess I'll keep it this way, because if you have the newer one, then it has just fill in the blank. So the other problem you asked is similar to 75. Useful life. It says the total accumulated cost, C of t, and revenues, R of t, in thousands of dollars respectively for a photocopying machine satisfy these two functions. T is time in years. For us to find the useful life, I need you to think about this. For it to be useful to a company, it's useful as long as the revenue is above the cost. Right when revenue and cost are equal to one another, cost will exceed revenue and it's not useful anymore. So when I have to find the useful life of a machine, I need to graph it. So I'll put cost first. 1 divided by 11, and I'm going to use x. Then this one I've got 5x second ln to the negative x squared. And I'm going to see where they cross. So now my blue, you'll be able to tell this. It's cool. The blue is the cost and the pink is my revenue. I'm going to do a zoom 6. So now blue is cost. Here it comes. And you can see the revenue, it's coming. So it does hit. Let me let that finish, because I think I'll go back to zoom decimal again, because you'll be able to see it a little bit better. So there's the cost. Here comes the revenue. What I'm concerned about is from 0 to where they cross. The negative time does not make any sense. So I need to see where they hit right there. It looks like it's near 2, but for me to do that, I've got to do second, trace, intersect, number 5, and I scoot it to where it looks like they hit, and I press enter 3 times. 1, 2, 3. My intersection is x equals 2. Now x is time in years. Remember I put x in for t. So my useful life here is just 2. So let me start writing out my function here. Ain't no good way to see this thing. I'll do it that way. So I'm going from 0 to 2. 0 is when they bought the machine. Now it talks about profit. You got to remember profit is revenue minus cost. So I don't want you to do these by hand. The big thing about the word problems is getting the setup. And once you've got the setup, then either go and draw it or put it in like I did a few minutes ago. Alright, so let me clear out of this. So I'm going to go do, I think I will change mode. I just think the other one's cool. So math, number 9. I'm going to put 0, 2 in here. 5, I'm going to go ahead and use x. I just like x. To the negative x squared, bring that back down, minus 1 divided by 11x. dx. Now if you put t's here, it would come up to be the same thing. So let's go see. The question was, what's the total profit accumulated during the useful life of the machine? And it was, the revenue was in thousands, so that would be 2.272 thousand. That would be my total profit over the useful life of the machine. So hopefully this will help. I'm sorry that it's long, but these things take a little bit of explaining to do. Thank you. Bye-bye.